You don't have to change your behavior, but you can also save the world. Isn't that amazing? Good afternoon to you all. Thanks for being here. This is CCU Taiwan iGEM team. Today, we're going to introduce our product, Liggreen. So now let's get started. In Taiwan, we've got the highest density of drink shops in the world, which causes numerous usage of paper cups. We wasted 1 billion paper cups per year, but seldom of them are treated in the right way in the recycling system, which causes serious harm in the environment. The reason why it is harmful is because to prevent the liquid from leaking it out, there is a plastic material inside the paper. And these microplastics has incredible endurance to exist through generations without being biodegraded, which is one of the mortal harm to our environment. Environmental Protection Administration in Taiwan has revealed an investigation that every 1,000 liters of ocean water will contain 1,000 to 10,000 of microplastics. Moreover, Orb Media has reported a study to test on tap water all over the world and found out that 83% of them are contaminated by microplastics. This phenomenon will gradually form a plastic ecosystem and is an unsightly and damaging blight on our environment, which causes a vicious cycle. By passing off through the food chain, it will be not long before the day of reckoning comes to human. Paper cups have to change. Therefore, our team aims to find a new material to substitute plastic lining. We are inspired from a natural material. It is a waterproof polymer in trees, which is lignin. Lignin mainly composed of 3 monolignals: synapyl alcohol, coniferol alcohol, and paracameryl alcohol. Unfortunately, due to its complex tertiary structure, the material is brittle and hard to shape. So, we choose one of the monolignal, coniferol alcohol, and hope it could become a polymer. So, our team aims to use enzymes to catalyze coniferol alcohol and to form our product, Liggreen. Now, Wet Lab will tell us detailedly about our gene design.
According to former speaker, you can know that we only use coniferol alcohol to form our enzymes, and also we follow the principle of how monolignals turn into lignin. The key is enzyme. In our experiments, we use lactase and peroxidase as our enzyme. Monolignals dehydrating by direct interaction of oxidizing enzyme. It reacts on specific points of coniferol alcohol and then generates 3 binding structures: beta-beta, beta-O4, and beta-5. It means coniferol alcohol reacts on. It means coniferol alcohol will produce dimers and oligomers. As for peroxidase, it will bond to the suspending lignin culture, cause radical addition of lignin oligomers to start polymerization. Then let's talk about how we choose our genes. We chose peroxidase from Picea apiis because that Picea apiis is the most common species using on application and research. And also, Picea apiis contains up to 94% of coniferol alcohol, which is similar as our project. The reason why we chose lactase from Hynes is that the most suitable pH value of lactase from Hynes is same as the most active pH value of peroxidase in Picea apiis. And also, both Hynes and Picea apiis have similar composition of monolignals. Then, we insert our gene sequence into Pichia pastoris, so it can help us to secrete the enzyme we want. You may be curious about why we choose Pichia pastoris, and there are 3 reasons. First, it processes early glycosylation, which lactase and peroxidase are required to modify. Second, it delivers high quantity active functional recombinant protein, which can help us to manufacture in the future. Last but not least, the expression vector can provide in PK pastoris can provide secretion signal for expressing protein and help us to purify protein more easier, also to save money. Then let's talk about our experimental architecture.
This is schematic structure of our gym experiment structure. We use Liggreen system to control to select cloning, and in the future we will use histone containing chain selection in order to keep the cost down. Then we test characterization by using different leucine concentration paths. Then select high copy number to check with after-tag by Western blot. After polymerization, we analyze the peak shown in UV visible and thermogrammetric analysis. The vector we use is PGAP-DA from in Michigan, and we insert our target gene to control our cloning. This is our gene design. From left to right, you can see gap promoter, which is constitutive type of promoter, Cossack sequence, initiating and enhancing translation. Alpha factor, which is secretion signal for directing secreted or recombinant protein. After that is our target gene, and tag for Western blot protein detection. His tag for protein purification. Lastly, LS1 terminator, which is common one in PK pastoris system. Up to now, you may already find out we just put only one target gene in this backbone. And you are right, it is important part of our gene designs. That is, our target genes are separated into 3 different inserts rather than put it in one. Why is that? Because this way gives us some benefits, such as it will help us more easily to debug, and we are able to identify products easily. Second, we don't have to worry about 2 of our gene expression competition during transcription. Also, we can keep 3 different enzymes in dry lab device. That it is easy to control the quantity of enzyme in device. And we use this integration system to perform its transformation, because circulate plasmids will be unstable in its cell and will be lost after cell division. So we perform linear plasmid transformation. After we cut FER2 restriction sites, P-gap will simulate homologous recombination, and our plasmids will successfully integrate into its chromosome DNA. Next, let's see our experiment results.
So, as the saying goes, easier said than done. So now let's take a look at our experiment result. First, in theory, higher gene copy a cell has higher ability to resist antibiotics they own, and also accompany with higher expression level. Therefore, simple antibiotic selection is not enough. We treat our colonies with different concentration of antibiotic. As you can see, from 100 micrograms per milliliter to maximum 500 micrograms per milliliter. Excuse me. This, we can dig into the relationship between the copy number and expression levels through this. So now let's take a look from lattice 1, shall we? As you can see, this is a growth curve of the lattice 1. When they reach stationary phase, it grows pretty stable. Thus, the Western blot is checked by the copy number. From low copy to high copy, the band does get brighter. Next is PX16. Compared to low copy and high copy, we assume that PX16 does have some negative influence to cells, such as cytotoxicity. Then let's take a look at the Western blot result. We found that the highest expression level appears at 72 hours. Also, why Western blot is checked by time point is that only low copy is shown, which makes sense if PX16 does have some negative influence. Next, finally, the PX18. You can see the growth curve drop from 72 to 96 hours. Then, compared to Western blot, You can see from 72 hours, the enzyme started to degrade. Same as pH 16, the enzyme may also have some negative influence to cells. And when they started to degrade, the growth rate started to raise. So far, everything looks perfectly. Yet, there's something that we could do improve is that stop using antibiotics. From the beginning of our experiment, pGAP-DA vector plays an important role on selection. It provides cells the ability to survive in an environment with zeocin, our antibiotic. But zeocin is also toxicity to mammalian cells, which my cousin Delph thinks our product will contact with human body. Also, zeocin is not only expensive, but also patented. After all, nobody wants to be sued by those biotech companies, right? So, things have to change. Introducing histidine and HIS4. Histidine is a crucial amino acid, and the function of HIS4 is to produce it. We construct HIS4 gene onto pGAP-DA vector and simultaneously destroy the promoter of the zeocin. Then, we transform it into the E strain SND1168, which is a histidine-defective E strain, and raised in histidine minus medium. This autotrophy selection will replace the traditional antibiotic selection in the near future. Now, we had finished constructing the vector, and colonies with PX18 has successfully transformed and survived on our histidine minus SD plate. Also, same as we mentioned before, we use homologous recombination with transformation. The digestion side is on HIS4. And now, it's time for our product analysis.
In product analysis, we start from calculating the Gibbs free energy to know whether the reaction is spontaneous. In oxidizing reaction, the change in energy is positive, meaning that enzyme is needed in the dehydrogenation of coniferol alcohol. As for the dimerization, the change in free energies is negative, meaning the reaction is spontaneous. We made free samples by adding lactase and peroxidase together and added them separately. After 4 hours of constant temperature reaction, precipitates were formed at the bottom of the tube. We assume that this product has the properties of insolubility. We then abstract this product by centrifugation and wash by water. In UV visible spectroscopy, we try to prove whether the reaction has occurred. Comparing the absorption peak of coniferol alcohol and our product, it is obvious that the reaction did occur, and our enzyme actually worked. From other studies, we know that the absorption peak of beta-O4 is left-sided compared to other bonds. Therefore, we assume that our product has more beta-O4 bonds, type bonds. In thermographic analysis, at about 100 degrees, our product has a better thermal stability than commercial lignin. The loss rate is 5%, comparing to commercial lignin, loss of 8%. However, our product is not well enough comparing to plastic. So in the future, we aim to adjust the enzyme concentration and reaction time to better improve our product. We take biosafety very seriously. In the design of our production line, we make sure no yeast can escape. 2 biosafety measures were taken. First, we separate yeast and enzyme by membrane filtration, allowing only enzyme to pass through. Second, our yeast cannot survive an environment above 50 degrees Celsius. In pellet forming process, the minimum operating temperature is 110 degrees. No yeast will survive. Now, let's see what we did in human practice.
In human practice, our goal is to make a real difference to society. However, by interactions with material experts, paper corporations, general public, recycler, and governments, we enriched our product to a new level. Not only adjusting our material to be more complete, but also devoting more to the society. We inspect social problems and propose policies. Also, we want to give the world a new generation. So we've separated 4 parts, and we'll start with integrated human practice. In the produce part, we interact with material experts and paper corporations, and we found out that there are some criteria that our product has to meet. And adjusting our experiment in the material and also production line, which could help us to be more suitable for paper corporations to accept our product. And next, in the user part, we have do survey to know about public thoughts, and found out that most of the people care about whether paper cups has go through food packaging safety statement standard. And we found out some flaws into it, so we want to add some policies into the regulations. And next, in the terminal part, we found out that the recycling system in Taiwan has serious problem. So we investigated the whole recycling system. And we found out that the recycling system can be more easier and more simple. And also, we want to add control collecting different kinds of trashes in different days separately, just like Japan. And also, by the help of Government Environmental Protection Administration, Deputy Executive Secretary Mo Wu, and also Lian Cai, the only one corporation that has the ability to recycle paper cups in Taiwan. And for their help, so we have more complete regulations in recycling system about paper cups. So you can see these policies detailing in Wiki, or you can find us in the poster. Next, also we went to find the policy. We meet the chairperson of Jiayi Silicon Cell, Xiao Shuli, and she said that actually our policies correspond with popular issue in Taiwan, so it has the possibility to carry out in the future. Next, collaborations. We're collaborating with by collaborating with different schools, we have improved our project. We collaborated with N1MU Taipei team to talk about Interlab, and BIT iGEM team for project discussion. Also, we went to NCKU Thailand iGEM team to talk about our problems that we met and how to solve it, and Mingdao iGEM team about debating synthetic biology. And in the public engagement, aside from doing survey, we held a genetic engineering lecture for senior high school students, not only talking about the knowledge of synthetic biology, but also popularizing iGEM competition. Next, fourth, entrepreneurship. This is a comparison of our product with PLA and PE, and we can find out that actually PLA have the ability to be biodegraded, but actually it needs high requirements, such as high humidity and high temperature. And also, because it is transparent, so actually usually people are being confused with polyethylene, which decrease the quality of recycled plastics. Okay, so this is our SWOT analysis, and our main strength is producing an eco-friendly product. But on the other hand, we've got high cost. Our opportunities are social trends because environmental friendly awareness has arisen, but our threat is consumer acceptance about synthetic biology. And also, we have built our business model. Our target customers are paper factories and drink shops. More specifically are those who cares about environment. And you can see more detail about business model in our wiki. In Liggreen, we have accomplished design a new biobrick parts, lacase and peroxidase, project discussion about synthetic biology, public engagement, holding a lesson, and survey to know about public thoughts, engaging experts to improve our project, modeling our project, product modification, demonstrating our enzyme functions. To sum up, it is everyone's responsibility to save the earth, but seldom of them are willing to change their behavior, and we will change it for you. These are the sponsors and acknowledgements that have helped us. Thanks for the help to affect our product and give us the opportunity to affect the earth, to affect the environment. Thank you, everybody. This is all for our presentation.
Is that the whole team? Anyone else? Do you guys want to go up? Or no? It's fine. Awesome. Great job, guys. Very interesting presentation. We'll open it up to